Yeah, unbelievably, I came down with a really bad cold suddenly yesterday afternoon. So I just want to say thank you to everyone who gave me medication, vitamins, sympathy. Also, of course, want to thank everyone on the ATD organisational team, especially Jose, Sabine, Uwe, and Alice Gute zum 10. Geburtstag. Happy 10th birthday, Agile Testing Days. I'm really happy to be here. So why me? Why am I talking about blockchain and crypto? That's me on Twitter. If anyone wants to follow me, I talk a lot about blockchain stuff, crypto stuff, and testing, because while I work some of the time doing some work with blockchain startups and so on, I'm still working a lot of the time for clients as a freelance test engineer specializing in automation and test tooling. I've got my hobby project, something more than a hobby project. We hit 500,000 page views per month in December. Count My Crypto, which is a cryptocurrency portfolio tracker. I'm a serial failed blockchain entrepreneur. I was going to put that in the slides, and I thought it sounded too depressing. But I've learned lots of things, including the fact that I'm a better techie than an entrepreneur. And I teach a blockchain quality engineering course. I write a lot about blockchain, and I've been running the London Women in Bitcoin meetup since 2014. I'm not going to talk much more about me, but just to give you context to all of this, why blockchain? Who in this room owns cryptocurrency? That's quite a healthy proportion, or it is on that side of the room. I don't know why that side of the room, not so much. But basically, how all this started was back in 2013. I was working for my client as normal. I was working with a couple of guys that I used to chat to a lot about Bitcoin. I've always been interested in financial systems. I did a BSc in economics. I was pretty obsessed with Bitcoin. In 2013, I decided that the price was too high. I think it was about £600 at the time. So I decided to invest, buy some Dogecoin. And if you haven't heard of Dogecoin, it's basically Bitcoin with memes, very cheap, a lot of fun. And I became obsessed with trading cryptocurrencies. So because I write tools and I automate stuff for a living, I was slightly annoyed by the fact that I had cryptocurrencies on different exchanges in different wallets. So I wrote a tool to pull all the prices off the APIs of the different exchanges. My other friend, Bruce, who I was sitting next to, Chris was the guy I bought the crypto with. Bruce, I actually built the website with. He's a front-end guy. My visual sense is zero, so I built the back end, he built the front end. And from that moment on, I became immersed in crypto Twitter, started talking to teenagers in the middle of the night, arguing with them on Twitter, which was a lot of fun. They all called me bro or homie or dude, which I found sort of slightly perplexing. And that was what prompted me to start London Women in Bitcoin. So eventually I became a lot more interested in the technology underlying cryptos. And I took an Ethereum developer course, and then when 2 years ago found myself in Switzerland at an incubator for blockchain startups with a couple of colleagues, and we prototyped an app. I had a lot of problems testing it for many reasons which I will describe, and that has kind of informed my understanding of testing blockchain applications. So what this talk isn't is it's not a how you debug a smart contract or what information you dig out of a Bitcoin transaction, because that's not really a keynote-y type thing. I do lots of other talks like that, but now's not the time and place. I want to talk about macro kind of issues around old technology, new technology, and our responsibilities, not just testing technology in a practical sense, but also thinking about the ethical implications of what we're testing. So before we go into the future, let's go back somewhat. When I was at university and I started working, Computers didn't look quite like this, but they weren't that much more evolved. They filled a room. And one of the things that we tend to forget, in the classic William Gibson quote about the future's here, it's not always evenly distributed. We have offices which have adopted technology quickly, offices which haven't. So I have worked in places where they were still working with punch card systems and which took a long time to get rid of things like that. And this is about the only picture I could dig out of anything relating to quality, going back obviously some time, and its quality control. And obviously, this could not be further away from our experiences now as testers and software professionals. We don't just sit here checking things. We do a lot more than that. But back then, or even 15 years ago, 20 years ago, it's very hard for people to move forward and envisage how things are going to be. So it's interesting for me that at this year's ATD, we've got talks on testing chatbots, AI testing, the VR session, which happened yesterday. Because going back even 5 years, I think people would have been quite surprised to see these as mainstream technologies so quickly requiring people to have workshops and sessions on how to test them at a mainstream software conference rather than a specialist conference. So when I'm asking you now to suspend your disbelief somewhat because blockchains as they are at the moment might not seem terribly useful in many contexts because they don't scale amazingly well. They have a lot of problems associated with them. But if you think back 12 years ago, how different, how many people here were working in technology 12 years ago? That's cool, half the room or more. Think about what your life in software was like 12 years ago, and think about how quickly things have advanced, and then extrapolate forward to a world that's going to be really different. So here's a map of some of the things which are already starting to inform the world that we work and live in, not just individually, but interacting with each other. You know, you might have an AR app that has IoT components to allow you to walk around a show home or something like that. You obviously have drones which use IoT technology. You can take a VR trip in a drone. All these things kind of are linked together. You might have any number of them in a project that you're testing. And one of the key components here is blockchain. To really illustrate this point, this graphic is just a really small selection of companies which have blockchain projects either live or in a pilot state at the moment. IBM, in fact, have more than 1,500 developers now working on blockchain projects, and it's quietly below the surface, below all the hyperbolic headlines about Bitcoin. It is slowly becoming mainstream. So we see here, obviously, not just financial companies. We see many different types of company. And I'll give you an illustration a little later in the talk of the type of applications that they might be used for. But before that, I'll talk a little bit about how blockchains actually work. I'd be interested to know, is anyone in the room actually working on a live blockchain project? Awesome, brilliant. I want to come and see you afterwards just to find out what you're working on and the challenges that you're facing. I'm going to use the Bitcoin blockchain as an example of this. But in terms of, and I should give a credit to The Economist, if you look at the slides on the bit.ly link later, you'll see it is actually an Economist slide, and I've given them a credit for this. Essentially, a blockchain is little more than a ledger, something that records a sum going from point A to point B, minusing from one place and adding to another place. And the transactions are linked together or bundled together into blocks. When I'm talking to less technical audiences, I probably shouldn't patronize you by giving you this explanation, but actually it's quite an easy to understand explanation. If you can imagine a kind of old style office where people bundled up documents into an envelope and sealed them with a wax seal, it's kind of like that. The transactions get bundled up together, and then that envelope gets linked to the next envelope of transactions in such a way that it's really difficult to undo. And those transactions are time-stamped and encrypted. But then, this is where the magic happens. This is not new technology. It's using algorithms that have been used for decades, and people have been working on time-stamped data structures for quite a long time before. But the magic thing about how decentralized technology works is that with a public blockchain like Bitcoin or Ethereum, anyone can download the software. Anyone can look at the history of these blocks which are linked together to the beginning of time. And each node, each computer which the blockchain runs on, validates the transactions. So that's rather like the difference of if you're a member of a village bowl society or something, and somebody, the treasurer, keeps the Excel spreadsheet on his or her laptop at home. They've got an Excel spreadsheet. You've got to trust that they're keeping the records correctly and not pocketing the money. But then imagine that if everybody in the bowl society used a Google spreadsheet. Obviously, that's not a direct analogy because Google is highly centralized, but it gives you an idea of this transparency that you get when everybody can see transactions. So you combine the decentralization aspect with the encryption and time-stamping aspect, and all of a sudden you get something that's like a back end that doesn't have to be protected by firewalls, that doesn't have to be kept secret, that people don't need passwords to access, because the security is baked into the architecture itself, not something that has to be applied on the outside. So in terms of Bitcoin, what it actually does at the moment, it's reasonably limited because, I say it's limited, it's actually not limited because you can send $30 million across the globe for a few cents and it gets there in an hour instead of having to go via banks and intermediaries. But in terms of adding functionality to that came a little bit later, but it's also possible to do interesting things with the Bitcoin blockchain. But in general, blockchains are useful because you can, because of the distributed nature of these data structures, you can transact peer-to-peer, rather like BitTorrent, same type of technology, without having to trust it going through something like a bank. And also, if you think about being a startup, it gives you a secure back end without you having to have specialists. Obviously, you need specialists to handle the integration or the layers on top of it. But it gives you this really, really high level of trust between people who probably don't trust each other, because the transactions are all agreed by the consensus of knowing that every node on the network has the same single source of truth. Zero downtime. Obviously, it runs in all time zones. If you've got a public blockchain, it runs in all time zones at the same time. And it's not just people who can transact via blockchain type data structures. It's devices. So we're now seeing the proliferation of either proprietary or different structures which are not quite blockchains, but which are which allow IoT devices to communicate with each other. And the big thing, the really interesting thing, is that used correctly, you can have control over your own data because you are identified on a public blockchain by a key pair, like a pair of SSH keys, the same thing. You can choose how much of your data you reveal to anybody that you're transacting with. So it's like the antithesis of the Facebooks and the Googles of this world. So far, so good. And rather like back in the early days of the internet, because people say that in terms of blockchain and technology and the internet were about in 1995 or 96. Anyone who was around then will remember what it was like using Usenet groups and having dial-up. The idea that one day you'd have movies streaming, even pictures, just seemed kind of crazy. But there were visionary people like Ray Kurzweil or science fiction writers who could envisage this future where the internet did everything for us. But then you have people who couldn't see this, and they really live to regret this. I love both of these quotes. At the moment, Paul Krugman, the Nobel Prize-winning economist, he absolutely hates cryptocurrency. So every so often he turns up on Twitter to say something very, very scathing, and people just tweet back at him, fax machine. Because once you've come out and said something like this, which is what he said in, I think, 2001, it's actually quite difficult to live that down. I'm actually quite surprised he's still making predictions. And Ken Olsen, Digital Equipment Corporation, might not be a household name these days, but it was very big in the 1980s, and in fact, Compaq bought it. And he said there is no reason anyone would want a computer in their home. And of course, we don't just have computers in our home. We have computers in our pockets, mobile phones more powerful than the computers that sent people to the moon. So sometimes we can be as bound by a failure of imagination as we can by over-optimism. So I'm fairly obsessed with Bitcoin. That wasn't a meaningful pause, it's just my sore throat. So everything, whenever I talk about blockchains, even if I'm talking about corporate private blockchains like Hyperledger or whatever, people always want to know about Bitcoin. So this is the obligatory Bitcoin slide. The Bitcoin white paper just had its 10th birthday. This is so significant because if you think about this open source software, which everyone in the world can see the code, you can have a look at it on GitHub, you can run it yourself. It's been going for 10 years without being hacked. That's pretty extraordinary. We're all testers in the room. I know there's a heap of security specialists here. I still find it absolutely incredible that this data structure, which transfers billions of dollars worth of value and is visible to everybody, that you don't need a password to access, and yet it's never been hacked. Exchanges, which hold your Bitcoin for you, have been hacked. They're always in the news. And of course, it's very easy for non-technical journalists to conflate this with the Bitcoin blockchain being hacked, but it hasn't. There's nothing else in there that you can really not find out yourself online. The 2,000 other cryptocurrencies, really worth reading up about some of these crazy things. The only thing I will mention is the Bitcoin pizza. If you know any people who are obsessed with Bitcoin and crypto, they do this thing in May every year where they get together and they buy a pizza with Bitcoin. Because in May 2011, the first real world, i.e. not online purchase, was made with cryptocurrency. People had used Bitcoin to pay for gaming rigs and so on before, but somebody, one of the original Bitcoin core developers, bought a pizza dinner, which actually it wouldn't be worth 65 million today because the price fell this afternoon. It'd be worth about 61.5 million. And the volatile price is one of the things that makes it interesting. But as the bottom line says, a lot of the reasons people are interested in blockchains, not just for cryptocurrencies, not just for financial institutions transferring different asset classes between each other, which is an absolutely massive thing, this ability to tokenize equities or other assets and exchange them in a trustless fashion. But blockchain technology, probably not as it is now, but as it will be in probably a reasonably short time, is useful for lots of other things. Being able to timestamp this data and have a distributed system where either anyone in the world or a list of permission signatories has access to the data, means that you have trusted data, and you can use trusted data for all kinds of things. Like, for example, there was a really interesting energy project in Brooklyn in the States, where houses who had solar panels on the sunny side of the street were able to use microtransactions running on a public blockchain to sell electricity to the houses across the street without people having to get involved. It's basically a way of automating in a situation where you have unknown parties or people that you don't want to go through the whole trust thing with. And shipping is a really, really good example of this, because the average container ship coming from China to Europe can generate as much as 2 kilograms of paperwork by the time customs have signed off in different countries and companies have signed off bills of lading and so on. And this comes about because companies don't trust each other. They don't trust each other to supply goods that are of the description they believe they're getting. Countries don't trust companies to import possibly illegal goods, and countries certainly don't trust other countries. Think about a shipment going from Iran to the States. You know, it's not even just the companies not trusting each other, it's at country level. So a consortium data structure, which is fundamentally untamperable, suddenly becomes a very interesting thing. And in fact, the first blockchain-powered shipments have already happened. Maersk have, among other shipping companies, have been running their own projects, and they've been quietly shipping stuff all around the world recorded on blockchains. The smart oil pipeline, being able to take data from individuals' weather sensors to predict oil demand in different parts of the world, while being able to trust that nobody's gone in, edited that data. So as a tester, how the hell do you test this stuff? With a public blockchain, it's phenomenally difficult. You know, the one thing that's really good, you don't have a back end to test because it's already there. It's out there in the cloud. It would be like saying, we want you to test AWS or something like that. It's being provided by other people. You don't have to test it. You test the integration points. If you've got APIs and a layer over the top of a blockchain, you test those. So that part of it's good. It cuts down on work. You don't have a back end to test. But you've got no control over environments. And when you have a publicly maintained, we all know that it's amazing working with open source libraries. They give us a source of richness and innovation that we often don't get when we buy proprietary software. But equally, we know, I don't know if anyone remembers, I think about 18 months, 2 years ago, the guy who rage quit his NPM module and unpublished it. And it was something that introduced 4 pixels of left padding. And it virtually brought the internet to a standstill because everybody was using it. When you rely on open source, you have governance issues. With public blockchains, the governance is public, so it's by public consensus. So you get situations where people, different developers, different miners decide that they want the network to work in a completely different way. And what do? You have a commercial application running on top of it. The other thing is the immutability thing. That's a massive thing. I'll give you a real example in a minute. You cannot roll back. If you push something out there, and I'll explain a little bit about smart contracts in a minute. If you push something out there, you cannot roll it back unless you've done things like built in a kill switch for a contract or something like that. But even then, it's very difficult to foresee, very easy to be wise in hindsight. And at the moment, you have to think about how your application will scale at a time when all the public blockchains are facing scaling issues. Also, an entirely new paradigm for testers. How much does that function cost? Briefly, with smart contracts, with blockchains like Bitcoin, which are designed to run purely for sending transactions, although there are other solutions like sidechains, which mean you can do more complicated things. But it's essentially a transfer of value mechanism. Since then, blockchains have come along, starting with Ethereum, where you can attach more information to this transaction, node-to-node transaction, which is broadcast to the network. And you can even have small scripts which run, small programs which run on every node in the network and are verified, executed and verified on every node in the network. The only problem with Ethereum, which is probably the best known public blockchain after Bitcoin, is that Solidity, the language that you write the smart contracts in, is absolutely horrible. It allows you to do all sorts of really terrible things. And one of those terrible things is writing an infinite loop, which every time it loops, it's going to cost you money. Because with a public blockchain, you have to pay people to maintain. Nothing comes for free, but instead of paying AWS, you're paying the people who actually own the computers that the network runs on. So you have absolute nightmare situations, like there were all these companies trying to raise millions of pounds at the end of last year, and an app development company decided to release a cartoon cat game called CryptoKitties, and it brought the Ethereum blockchain to a standstill and made prices go up like that. And these poor people had to delay their seed round because the whole network was blocked up with people breeding cartoon cats. You couldn't make it up. There were some amazing memes. Just look up CryptoKitties and you'll see what I mean. You also have things like, as a quality specialist, you need to educate your user who's not used to this type of application. You need to warn them that once their data's in there, that it's going to be there forever. And the other thing is the big question of whether you build in kill switches. So this is a useful graphic inspired by a really interesting guy called William Mugia. It's not directly taken from him, but he wrote one that was kind of like this. It's a summary because you can divide up blockchains into the public ones where anyone can download the software, consortium ones where you might have several companies like banks, for example, all getting together to have a collective blockchain, or you can have private ones. And most people are quite skeptical about private blockchains because, you know, the cliche is it's a slow database. It sort of is a slow database. It probably has some advantages for auditing because of the immutability, and when the auditors come in, they can immediately see that people haven't tampered with it. But in my view, the private blockchains using various technologies that exist are probably the intranets of today. I don't know if you remember, but way back when the internet was still in its infancy, intranets were a real thing because rather like the change from APIs to open APIs, companies were really suspicious about why would we use this public thing. I think we're very much at this point with blockchains where people are going, yes, we're just going to transfer our traditional business model where we have private data to our business. There's obviously some cases for it. So there's a blockchain startup based in Berlin, which is a pretty awesome company. Really clever people work there. If you are involved in blockchain, you'll probably know who I'm talking about. I'm not going to call them out because it's a bad thing to do. But they made a fundamental error about, I think it was a year ago. They pushed out a smart contract which laid the foundation for a multi-signature wallet. Now, a multi-signature wallet is just a way for people to participate collectively in holding cryptocurrency. So, and a lot of companies who are crypto-focused use these multi-signature wallets instead of a company bank account. It just means multiple people hold keys which they can sign transactions with. They pushed out a change at this company to their very, very popular multi-signature wallet, which it didn't mean that the wallet got hacked. It meant that millions of pounds of people's money actually got locked up. because of a really something that looks very easy to overlook in hindsight, but it's a tester's nightmare. Somebody who was poking through the code on GitHub, somebody who we still don't know their identity, it claims to be a newbie, but people are suspicious, decided to invoke a kill function, which had been left public, killed the contract which runs these wallets, and the money's still locked up. Nobody knows what to do with it. But you've got to really think about how the testers and developers on that project felt. They woke up in the morning and it was a firestorm. It wasn't just their customers saying, "What have you done? We can't access our money. Will we ever get it back?" It was everywhere. And of course, the code's public. Everybody's looking at the code going, "Oh my God, how did they do that?" And they have no solution for it. They couldn't roll back. Normally, it's a bad mistake if you're involved in a project like that, but you normally have a solution for it. You can roll back. Testing on a project like this, you have to work with the knowledge that things like this just aren't possible. Now, ethics, I think, are incredibly important. I've started noticing over the last few years a lot of people doing great work with talking about things like dark patterns on web applications and mobile applications, where people have been asked to test things that have an undesirable outcome for the user and a positive outcome for the business. So a cancel button that's difficult to find, or a submit button that looks like it's the only button you can click on the page. And I think now, with a lot of these technologies that I showed you on the kind of cloud graphic before, like AI, like blockchains and so on, we have to think at requirements stage about the abilities that we're giving people. Because if a company or a government deploys something like this, the tech is just a lot more powerful than stuff that's been out there before. So you have to take responsibility for things. The thing is, with a public blockchain, nobody's in charge. You can deploy software that people can use for almost any purposes. We all know that technology's agnostic. It's neither positive or negative, neither malevolent nor benevolent, but people can be either. And how people use our software is completely out of our control once we've pushed it out there. So there are all kinds of ethical things you have to think about when you're testing. And one of the things that I feel most strongly about, there's been a lot of conversation over the last 3 to 4 years about central banks and cryptocurrencies. And even today, I saw at lunchtime, Christine Lagarde was talking at an IMF meeting, and this idea of programmable money, that you can have smart contracts to release cryptocurrency for specific purposes, and thus the extension of that is you can use it to manage economies. That is seen as a positive thing by some people in the blockchain crypto development community. I think it's incredibly dangerous. Why do I think it's dangerous? This is WeChat and the Chinese social credit app. I'm figuring most of you in the room have read about the Chinese social credit system, which started out as a voluntary kind of gamification thing and now is becoming compulsory, where you get demerits or plus points by interacting with people in a socially healthy way, which means not criticizing the government. And it can also mean things like not jaywalking. I read something recently about the Chinese government having paid to develop, there's an AI which recognizes people by their walks, so that if you wear a mask or a hat, you can still be recognized just by the way you move. And they're combining this with this social credit system to control society in a way that's really not healthy. And when eventually they move to a system of digital currency, because there are lots of governments around the world which are experimenting with blockchain-based national currencies already. The Bank of England actually did a pilot 3 years ago, and Russia's is quite well advanced. I was at FinTech Japan 2 weeks ago, which was pretty interesting, and I spoke to a guy there who was actually working on that project, which was super cool. But when governments are in control of digital currency to that extent, and there is no cash, and you're testing on that project, okay, so it's perhaps not reasonable to say push back against the government. But if you're working on private technology that you think could be used for malign reasons, I mean, people might see it as positive. For example, Japan. I'm not going to let this turn into an economics lecture because we're running late and everybody wants their dinner. But in Japan, they have had massive deflation over the last few decades because of local customs and demographics. In Japan, people tend to save a lot of money. In Anglophone countries, there's a real reliance on debt. Germany's somewhere in the middle. So when Japan were trying to inflate their economy and use fiscal and monetary tools to do this, they effectively started cutting people's tax. They even gave people money to go out and spend in the shops to boost the economy, and it didn't work because people saved it. They just thought, great, we can add that to our savings account. But the idea of programmable money, which cryptocurrencies essentially are, and smart contracts essentially are, means that you could target money. You could say, this cash will expire unless you buy a sofa within the next month because the furniture making industry's on its knees. Or this tax credit's only valid for vegetables because you want to... I'm a vegetarian, you think I'd be really happy about that, but that kind of control is not healthy. It's being taken to extremes in China, but if you're working on not a government project, even just a small blockchain project, just be aware that things like criminal records, medical records, even if they're encrypted, what happens if they're on a public blockchain at some point in the future? And the processing power of computers increases to allow people to easily decrypt information that shouldn't be there. There's a whole debate about blockchain and GDPR, which is also really interesting. So the message, be careful what you wish for, because once you have something like government programmable money, social credit systems, scary robots, AI, we're looking at a world that maybe we don't want to live in, or maybe we don't want the people who come after us to live in. We're working on software projects. We have that responsibility to think about requirements and think about what we're doing. And I think it's quite a burdensome responsibility once you start thinking about it. So the takeaways from this: blockchains are useful for lots of things. They're also not useful for lots of things because they're very slow, and we've seen a spate of startups recently. What about Deliveroo but on a blockchain? If you want your dinner to be on the blockchain, really, you've got a bigger problem. There are so many things that they're not appropriate for, and I'm glad we've seen the subsiding of the hype. Think twice about storing data that you might need to delete. An amazing number of product owners, CEOs, don't see a problem with storing medical records and personal stuff on blockchains. Our job to educate them. Private blockchains, there's a reason for them, but not all the time. Think about the future. If public blockchains will scale to a point where they can be used instead, bring an enhanced level of trustlessness. Governments and programmable money are a bad mix. I could talk about that all night. Take responsibility for helping build the world that you want. Because in the end, software's not about software. It's about people. We're building things for people. Even if we're working on systems where other systems consume the information, the beneficiary at the end of this should be a person, because Skynet hasn't happened yet. So really, my message is software's about people. Let's take our responsibilities seriously.